Hello, everyone. Today we'll be talking about fashion attribute classification using deep learning. This project is presented by Elizabeth, Amanda, Idris, and Lufe. As an introduction, the point of this project is to enhance the accuracy of fashion trend predictions and to help retailers identify fashion patterns as a means to help them try to reduce fashion waste. Um, and in this project, what we'll be doing is comparing different deep learning techniques to try to classify dresses by length. The dataset we were given consists of 11,976 images of specifically women's dresses. These were provided to us by our external client, Pendulum Fashion. Of these dresses, there's quite a variety in lengths, styles, and colors, but they are categorized into three dress lengths. Those are mini, midi, and maxi, and these lengths are defined based on where the dress hem falls along the leg. And so these images exhibit quite a lot of variation in terms of like image resolution, how complex the background is, the poses, and a number of people in each of these images. But we'll be talking a little bit about why this makes a difference in our classification task.
Yeah, from these images that we received, as you can see on figure one to the left, there are a variety of diverse image types. On the left, you can see that there's like non-full body images, so like the way they take the image is like from different angles. In the middle, you can see like some of them are standardized, so there's like blank backgrounds. And on the right, you can see there's different posing and lights and backgrounds. And from the different batches, there's different types of these styles of photography. Additionally, from the EDA, we looked at the distribution of dress lengths and we also looked at anomalies and outliers. So, first, we found that the data that we were given was fairly balanced. So, about 4,000 images with each of the different classes, MIDI, MIDI, and Maxi. Additionally, we found that there were different image sizes for each of these batches. And also there are a lot of outliers that we found, but we had chosen to include, we found at least 80 in the first batch. And on the right, you can see some examples of these outliers. Um, so in the first one on the left, you can see that there's multiple people in these images, which make with dresses, so it may make it more difficult for the model and for a human to decide which dress to label. And then on the second one, you can see that there's cropping involved, where you can even see like where what the length of the dress is. And the third, you can see that there's like other objects that might make it difficult to decide, um, like what the dress is or get distracted by it.
And for the methods, we leverage four different deep learning models. Firstly, the convolutional neural network, the CM model, and secondly, a residual neural network. And we also tried the OpenAI's contrasting language image training model, the FLIP model, and finally, a vision transformer. And in terms of the results, you can refer to the table on the right. So we present the accuracy of the four as well as some other metrics. And as you can see, the CN and fine-tuned ResNet 50 shows best performance. Each surpass an accuracy of over 85%. And conversely, the best flip and fine-tuned vision transformer models have lower validation accuracy of about 56% for each.
So our conclusion that we came to was that our CNN and ResNet 50 architectures were our most performant based on the metrics that we used, and that these two methods also were the best specifically on mini dresses, and the longer dresses were much worse. But notably for the clip and vision transformer models, they perform much worse on MIDI dresses, and we believe that that's a major contributor to their lower performance, um, especially in their recall. And since they have such low recall in the MIDI dresses, it kind of reveals that the models are more or less guessing at the extremes of like mini dresses or maxi dresses, as opposed to the middle MIDI dresses. Um, and for our better performing models, the ResNet and the CNN, they just seem to be having much more trouble with the longer dresses like maxi. And many of these images we found in our analysis were actually mislabeled in the data set. And you can kind of see some examples here in figure 4 on the left. Uh, they're, these predictions say that they are mini dresses and they look like mini dresses, but they're labeled in the data as maxi. Um, and on the right of figure 4, you can see that that's an image that's just like impossible to tell, even for a human, how long the dress is. And so we can see in figure 5 that there's a distribution of confidence for our incorrect predictions. And there's a lot of misclassified images with high confidence that may be like the cases that we saw in figure 4, indicating that one of the next steps is investigating the data set quality. Thanks for listening.